Good morning everyone and welcome to this new video. Today in this video we are going to solve a project that has been given by IIT Madras. Since everybody knows that IPL is going on, IIT Madras has launched a project which we have to solve on predicting IPL outcomes, and it's an interesting project. And the good part about it is last year I did one of a workshop by scalar.com where the guy there he taught us how to assess a IPL data set and make the prediction system. So I think it won't be too difficult for me to complete the project and submit it on time. So as you can see, I have received an email 2 days ago from IIT Madras, and they told that they have updated everything, the data set we are going to use. And I have visited their site, and here it is given that we have to install a Docker image and then start our project. Or we can make the project by downloading the data set and then import it to the Docker image and then zip it and send it to them. But I think I'll be using the way it is mentioned in the website. Like I have downloaded Docker here, and what is the problem statement? The problem statement here is given certain input parameter regarding the innings of an IPL T20 match. Predict the total runs scored by the batting team at the end of 6 overs. So at the end of 6 overs, maybe we haven't seen the data set, so we'll be considering the last run scored in last 5 overs, how many wickets are down, and the previous data, and then assess it. We are going to use multiple algorithms here. I think SVM will be used, linear regression, of course, and we have to use this hyperparameter optimization because the file size allowed is 5 MB and we only will have 20 seconds. So we have to make an optimized model, of course. So here they have given the data that will be there in the Docker image. They have two CSV files. One is the one with the record of each ball, and other is the outcomes, I guess. Yeah, the columns names are self-explanatory. When we go through the data set, we'll come to know. And yeah, that's it. The steps are as simple as it is written here. We first install Docker Desktop. I personally have never worked on Docker. I have always used GitHub, but everything is first time for in at some point of our life. So we have downloaded Docker, and we are going to give this command to download the image. The image will contain everything that we will be needing, and these are the Docker commands we have to use in order to download and submit our project through Docker. And how will our code be evaluated? Our model will be evaluated in a very similar process as the one you use to train your model and make prediction. The same Docker image will be used for evaluation. Your prediction will be evaluated against actual labels. The evaluation metric used will be MAE, that is mean absolute error. We mostly use this only in many of the project. Your model will have 20 seconds to run and produce predictions. If your model takes more longer than 20 seconds, the evaluation process will be stopped and your submission will be considered invalid and discarded. So these are the guidelines, and now we are going to complete our setup and everything, and then we are going to see on how we can achieve our end goal.
One eternity later.
So apparently this is the third time I will be trying to download this Docker image. I have wasted around 4 GB around 6 GB of my internet just trying to download the image and make it run. But for some reason, I am not able to figure out how to use Docker properly. And this will be my last trial. After this, if it does not happen, I have to, go through the documentation and all and learn how to use Docker first and then go to the code. But that would require time, and the video has to be released today itself. So apparently I will not be focusing on, the submission and their environment. I'll be making the model today because that is what I'm good at. And we will figure out how to do the Docker submission and, setting up the environment later on. We can copy paste from our Google Colab if there is something called a new terminal or something they'll provide or not. I have no clue about that. But whatsoever, I'll try this for the last time and hopefully it works. Otherwise, we'll proceed to our Google Colab and just work on our model first and then try to figure out what this Docker does and how we are supposed to proceed in it. So yeah, I have to open my terminal here. I have to give this code which is written here. Wait, I'll open it by administrator because I think that can also be an issue. Open with administrator, run as administrator, and yeah, we are going to do this Docker pull swar whatever it is. So Hopefully, yeah, it works fine. The image is created, but I am not able to find it on my local machine for some reason. After I have downloaded, I have pulled the Docker image. There is this issue of not being able to find my Python file something, and something is written here: create a project directory with following files. But how do I create that project directly, and how do I open my Docker image and in that project directory? I can use CD or mkdir in my CMD to create a project directory, but I don't know how to open my Docker there. So this is a little complicated. They should have just given it up on GitHub, which is far more easy. Like, who uses Docker? The YouTube tutorials I searched for, they are 7 years ago, 6 years ago. I could not even find a proper tutorial. Then I asked ChatGPT how to go about it. I just saying install a new something, a new IDE and do this, write this command, write that command. But I tried, but it is not happening. Hopefully this time it is perfectly fine. And congratulations to wasting more net. And if you can hear some noise in the background, it's probably the AC. My mind is going to burst. The level of frustration of wasting net and not getting the outcome gives to me is unmatchable with any level of frustration. So I need a cool environment. Therefore, I switched on the AC. And let's see what happens. I'll continue the video once we have downloaded we have pulled the Docker image. So as you can see, we have completed the pull request, but now what to do? That's a very interesting question because if you go to the Docker desktop app and you see the logs, there are some logs which are telling that there is no my model file found. And if we go to the website, we can see that it has written create a project directory with following files, but I don't know what is the command and where to put the command. I tried to put in the Windows PowerShell, but it did not work. I tried with the this terminal. I don't know, it is not working. So what I'm going to do is I'm manually creating a new folder called the IPL prediction system, and I'm going to open the terminal here. So we'll just close it now, and we'll open the terminal here. And we'll do docker run, I guess. No, docker run. What is our file name? It's swa whatever it is. We'll copy it. I don't think we need the latest. No module name my model file. I have no clue why this is happening. Let us create whatever it is mentioned. I will create it here. Create my model file.py. So we'll do new. Uh, I don't know. I'll open with VS Code and do something. Open with code and we'll create a file called my model file.py. So my model file.py. Done. And write a model codes in this file. Do not change structure. As you may create but it has the important unit. You can use fit predict. Okay, done. Let us see. I hope that this works now. So we'll open a terminal. We'll do docker run. Please. No. From my model file, import my model. No, my model. Terminal. Go to the terminal. I'm trying my best to understand how this works. Okay. And pip install. What is the file name? I have no idea. No idea. Import my model. Let us see. My model. Could not find. I have no idea what this is happening. Import my model. Let us see. Let us run the command again. No. I think we have to come back to this. I have no clue why this is happening. We'll just use Google Colab for now and make the system, and then we'll see what to do. What is this? Project.dr. God damn it. Project_dr. Where is it open? I don't think it is open. We'll close the Docker for now. We'll rename this as project_dr. God damn it.
One eternity later.
Update. I tried various ways of downloading it through Docker, but successfully I have failed to download by any way. So what I'm going to do now is we are going to just proceed with the project. I'm going to show you what a random tree classifier algorithm is and how it works. And then we are going to implement the model in Kaggle only where the data sets are there. So I matched the data set of the data given in the websites of IIT Madras and the one in the Kaggle, they both are the same. So we are going to do it in Kaggle itself, and maybe I'll write a mail to IIT Madras and ask them if they can provide an alternative for it, or maybe try to watch some proper tutorials and again do it. And yeah, hopefully that's how things are going to proceed. And now I'm going to show you how a random classification, random decision tree works. Yeah. So welcome everybody. Now we are going to discuss what a decision tree algorithm is, we are going to use a random forest classifier in this IPL prediction model, and that is why we must first understand how does a decision tree actually work. So as you can see, a decision tree model, what it does is, say for example, you have a big data set, like a huge data set. You take out some samples from it and some features from it, and you divide it into random forest that is called, say, tree 1, tree 2, 3 and 2, 3n. Now what the thing is, when you divide it into these random trees, you will give each tree a different subset of features. What I'm trying to say is, for example, in the IPL case, what are our features? Our features will be venue, batting team, bowling team, runs left, balls left, and wickets left. However, there are many things that are given in the dataset like temperature, player of the match, etc., etc. But we are going to eliminate those when we coded the model, and we are just going to consider these six parameters of features that we are going to use. So what random forest classifier are algorithm is going to do is, it is going to take these things from the dataset and randomly classify it into each tree. So there will be some data from training dataset which will be corresponding to venue. In another tree it will be batting team. In another tree it will be both venue and batting team. Like that, it will try several hundreds of combination with each one of them, mixing each one of them, taking different type of dataset, and that is why it will give us various classes, class A, class B, to class N. So there will be as many as classes that the patterns and patterns that can be recognized by our algorithm. After that, they will do a kind of voting that which of these is the best fitting model. What happens there is underfitting or overfitting in machine learning models. So to avoid that, random tree classifier is also a great algorithm because it takes the majority votes on the best one, and hence in even logistic regression or linear regression or other classification algorithms are not as powerful or as accurate as random tree classifier in majority of the cases, and hence it can be both used in a classification problem or a regression problem. So it will take a majority vote and give us the final class. This final class will be our algorithm provided data that is accurate and can be used to test split to X train, Y train. So this is how a decision tree works. And to reduce the to reduce the number of errors in decision tree algorithm, we use something called the mean squared error. I think if you are a machine learning learner, you have come across this term very early on your machine learning stage. So it is basically a function. It basically uses cost function to reduce the error. The cost function formula, many of you know, that is 1 by n summation of y1 minus y1 cap square. This is used to reduce our errors in the random classifier model, and hence we are going to use this model with these variables: venue, batting team, bowling team, runs left, balls left, and wicket left, to predict who is going to win a particular match. I hope you understood a bit about random tree classifier. Even if you did not understand, you can research on your own. You first need to learn what is decision trees. If you learn decision trees, there are so random classifier will just be many decision trees working together. That is what random forest classifier is. You can see there, multiple decision tree working together will give us random forest classifier algorithm. So I hope you got my point, and let's proceed directly to the code now. The dataset which we are going to use, I have opened it on Excel so that you can just have a glimpse of the dataset that I am going to use. So this is the delivery dataset that gives us per ball data. So say for example, on the first ball of the first over of the first match of the, which has a match ID of 1, we have David Warner as the batsman on the north striker, and we had S. Dhawan, and the bowler was T.S. Mills. So how many runs were scored? Total runs that were scored are 0. There was no extra run, batman run, by runs. So these all data is there in this data set, where we are given ball by ball data about the matches. So this is a very important data set, but we don't need many of the things here. We don't need super wide, by, leg by. We'll just remove them in our data pre-processing time. Then for example, we have to remove this by runs, Y runs from the total runs, because we only need the runs scored by batsmen. We don't need who the bowler is, who the non-striker is, who the batsman is. We only need the teams and the runs from this data set. So this is the first data set which we are going to use. The second data set which we are going to use are of the matches, who won the matches, where was the venue of the matches, say city, date. We'll remove this value as null values. We just need team 1, team 2, city. We don't need the toss factor here because we are not going to consider the toss. We are not needing the player of the match, who were the umpires. We won't be needing these also. I think there will be a huge time that will be invested only in data pre-processing instead of modeling. So it is going to take a lot of time. So let's just start without further ado. So I have my Kaggle open here. I thought of using Jupyter or Colab, but since the dataset is there in the Kaggle, so directly we can import it. And it's I have been using Kaggle for last 1 week, and I find that it's very nice. I mean, it's the user interface is clean. So first of all, we'll import the libraries. Import pandas as PD. Import uh, NumPy as NP. So that is our first. We imported the libraries, then we will import the data frame one. That is the data frame one, and we'll do pd dot read underscore csv, and I have copied the link from before. I hope this is the link. Yeah, this is the link hopefully, and something is missing. And df dot one dot head, and we'll see if it's coming. Invalid syntax. No, this is wrong. We have not got the correct ID. Oh, we have to this. I hope this will be fine now. Yeah. So now we have the data set loaded in our Kaggle notebook, and as you can see, we have the ID, city, date, player of the match, venue. This is the matches one. There are two data sets as I showed you. Let's load the second data set also. So we'll load the second data set as df2.
One eternity later.
Taken the data, we have pre-processed it, we have modeled it, and we have evaluated it, and it has given an incredible evaluation result. It is around 99% true. So what we have done in the code, let's just revisit everything we have done in the code. So first of all, we have imported the data frames. Then we have merged both the data frames on the basis of their IDs. So you can see 01234, 01234, both have similar IDs. So we can merge them using the merge function. Then we have removed all the things that are not necessary for us, like date, city, player of match, result margin, player dismissed, etc., etc. We have removed everything. Then what we have done is we have pre-processed the data. We have removed each and every null value. We have removed whatever is not required, and we have gotten to our 7 variables, which I mentioned in the video where I was explaining random classifier regression, and we came to that data as our final data frame. You can see some errors here which are there because I don't know, Kaggle has some errors with pandas. The next thing which was very important to do, and which the scalar one which I learned last year, they did not do, was removing teams like Daily Daredevils or Weekend Charges who have been converted to either new teams, or some teams are just removed. So we have used the drop function to remove such teams like Gujarat Lions, Rising Pune Super Giants, or Pune Warriors. We have removed such teams. I could have added the 2 new teams, but I thought they have just played one IPL, so taking their data into consideration, that would not be required for us to make a prediction system. Next, what we have done is we have gotten to our variables which we need. That is venue, over, ball, batting team, bowling team, target. No, this is not the final one. That is the one we remove more things, and finally we come to our data set which is pure and which we need. So this is all pre-processing of data. It is called EDA, exploratory data analysis. I think that's the full form. That's what is done here. And then the next thing was one-hot encoding. Now this term one-hot encoding is converting the strings into numbers so that we can use it into put into our algorithm, because our algorithm cannot understand what is Wankhede Stadium. We'll specify some number to Wankhede Stadium or some code to Wankhede Stadium. That's what here it is done. For example, venue 13. 13 means I'll get that is given below. So we have changed the string to a number. So everything is in numbers now. You can see here in this data frame, everything is in numbers, and that's what we require. We require our data in numbers so that we can assess it and give the algorithms there. So like here you can see Firoz Shah Kotla has been assigned with the number 8. Wankhede Stadium has been assigned with the number 29. In that way, all the stadiums have been assigned with the number. Similarly, all the batting teams, all the bowling teams have been assigned with the number. So for example, Royal Challengers Bangalore is number 6, Kolkata Knight Riders is number 3. Say bowling teams also we have assigned the numbers, and this is our final required data which we needed, and we have the data in form of numbers. So the last thing and the most important thing about a model is modeling it, and we have used the random forest classifier as I mentioned to model it, and we have trained X, trained Y train, and as you can see here, the training data is 99% and the testing data is 99% accurate. So let's just try it on today's match data. So today is a match between Kolkata Knight Riders and today is a match between, let us see whose match today it is. IPL 7:30. We have today's match is between Say for example, let's take yesterday's match, Mumbai Indians versus Chennai Super Kings. So the batting team was who was the batting team? I think it was Mumbai Indians. So Mumbai Indians has four. So our data should be in this format: batting team, bowling team, venue. So batting team four. So we'll type here four. Our bowling team is no, our batting team will be CSK. We are considering the second innings. So our bowling team will be four. Our batting team will be zero. And then our venue was Wankhede Stadium. So the code for Wankhede Stadium is 29. 29. Uh, say for example, how many runs were left? We had say yesterday's match, right? Let's check it out. So CSK versus MI, and this is yesterday's match. Let's go to the commentaries to find out commentators. Say for example, at the end of over 14th, CSK was 125. Okay, so they were 125. So what is our what is our, we have to put in the runs left. So what was the target here? 159. 157 was the target. So we'll put it here. 157 minus how much? 157 minus 157 minus how much did they score? 125. So we had 32 runs left. Not this one. This one is the trial one. We had 32 runs left. And how many balls were left? We had 6 overs, right? So we had 24 balls left. And how many wickets were left? So we had 8 wickets left. So we had 8 wickets left. Let's see. So it shows us that CSK had a chance of 94. CSK had a probability of 94%, and that's what happened. CSK won the match easily, and hence this is how you make a model that can predict who is going to win, the chances of who is going to win. There is a video by Krish Nayak, a very good machine learning developer on YouTube. He has made a model where ball to ball, it is giving the percentage, but it is not as accurate as this. I think he has used another subpart of random tree classifier, that is the ERM classifier. And like this, you can make many models like for the Cricket World Cup or Big Bash League or say Ranji Trophy. If you have the data, you can make models and predict who is going to win the match. So don't use for betting, but yeah, that's how you make a model using random tree classifier. The whole tutorial will be out soon. And till then, I would like to bid my bye-bye. And that was from my side, and hopefully you learned something. And the topic of this video, the IIT Madras thing. So what happened was I was coding, and I went to that website of theirs, and IIT Madras, right? So I went to their website, and what I have made is actually a pretty standard, good, and amazing. That's self satisfaction, but pretty good model about who is going to win the match. But that is not what was asked. It was asked to predict the total runs scored of the batting team by the end of 6 overs. So we would have used a linear regression model. We would use a linear regression model or a random tree regression model or a regressor model. Here we have used a random tree classifier model. There is a difference. I told you while explaining the algorithm that it can be used for both classification as well as regression. In this question, we had to use a regression model, and in the first cell, it's in the first cell itself, in the second cell, or here it's given 7 cell. In the second cell itself, we had to limit it to the 6th over. Like the 7 over, this data had to be removed, and then a prediction system had to be made. So I think I'll release a part 2 where I'll be doing this thing. Now, when I realized I have been doing wrong, I was too further down deep inside the project to go back, because after that, okay, I cannot send this, but I can add it to my resume, I can add it to my portfolio. So why should I leave such a good project midway? But it was an amazing project, this IPL prediction system. Every machine learning enthusiast and a cricket lover should try this system and try it on real life. I'll be trying it on real life in the upcoming matches, and let's see whether the accuracy that has been provided is correct or not. And for this 6 over thing, I'll be making another one tomorrow or probably day after tomorrow and releasing it in less than a week. So yeah, this was the first part. Signing off. Hopefully you all have an amazing day ahead.